so we'll remember, P is what? No, what is P? P is 2 and Q is 6. So P over Q is 2 over 6, which is, right? And so you've got, it means the factors of 1 are plus and minus 1 over plus and minus 3 and plus and minus 1, right? Does that make sense? All right. All right, so the possible roots, plus and minus 1 and plus and minus 1/3. Not 3, because the 3 is in the denominator, not in the numerator. What do you mean? I can have 1, -1, 1/3, and -1/3. You said 3. Right. They're not all going to work. These are possible roots. Where this is work 3 of them, right? All right. Okay. Descartes' rule of signs. This is kind of interesting because this is a way that you will limit the pool of possible roots. So currently I have 4, okay, from this plus and minus 1 and plus and minus 1/3. Descartes' rule says you use it says use to determine the number of positive and negative roots. It'll tell me I'm going to have 1 positive root and 2 negative roots, or something like that. So if you want to look at the number of negative roots or positive roots, use a given polynomial and look at the adjacent sign changes in the problem. So for example, x to the 4th. This is a positive or a negative term. Would you agree that I have a sign change? I go from a positive to a negative. Okay? Would you agree that between here and here I have a sign change? I have a -6 and a +1, yes? All right. Is there a sign change here? Is there a sign change here? So how many positive roots are there? Well, I have 2, or if we can always go down by a value of 2 without going in the negatives, 2 or 0, because we go down by 2 always.
So if you had 4,
it'd be 4, 2, and 0. Okay? Now then, it always goes by 2. So if I had 3, let's say I had 3 sign changes, I would have 3 or 1, and I wouldn't have -1. That wouldn't make sense. Okay?
So just your lowest possible.
Right? Right. All right, negative roots. You do the same thing, but you first substitute a negative x into your given polynomial. So negative x to the 4th minus 6, negative x to the 3rd plus negative x squared plus 3 negative x plus 2. This is x to the 4th, correct? This is 6x. This is x squared. This is negative 3x and positive 2. Thank you. Is there a sign change? How about here? Is there a sign change? No. Is there a sign change here? Is there a sign change here? So that means I will have either 2 or 0, because I'm going to go down by 2 again. Negative roots. Which probably means I'm going to have 2 positives then and 2 negatives, right? Because I'm using the same polynomial, right? And I need to have a total of 4, yes? So this just makes our P over Q pool a lot easier to work with. All right. So what is, determine the number of possible positive and negative. So positives are easy. We just look at our sign changes in the existing polynomial. How many am I going to have? I'm going to have a sign change here, yes. And where else am I going to have a sign change? So that means 2 or, all right, now let's do the negative. Then the negative, we've got to change our polynomial by substituting in negative x, correct? That's going to still leave me with 2x to the 4th, but this becomes x cubed. This stays negative 2x squared. This becomes negative 5x. This stays positive 1. Right? I'm doing this in my head. Can you see that? Y'all okay with that? All right. Any sign changes? How many? 1. There's 1 here. And down here. So 2 or 0. Well, just tell me positive 2 or 0, negative 2 or 0. All right. List the possible roots, list the degree, find the roots. All right. How many possible roots can I have? Determined by what? Okay. What's my degree? All right. How many positive roots am I going to have? 0. Let's do the negative. The negatives are going to give me negative x cubed plus 8x squared minus 16x plus 5. How many negatives? 1, 2, 3. So 3 or 1. Look at this. I just determined there are no positive roots. Why on earth would I try using a positive number when I do my synthetic division? I'm going to check all my negative roots. Do you see how this just limited your possible pool by half, basically? Because I know I'm not going to have any positive roots. All right? So we're going to do our p, which is plus and minus 5, and our q, which is plus and minus what? 1. Because we're always going down by 2. Remember in the other ones it was either 2 or 0. Because if we can subtract 2, then we take away a value of 2. Maybe there's only one distinct root, and they're just repeating themselves. Okay? All right. So p over q, 5 over 1. So plus and minus 1 and plus and minus 5. But am I going to try any of the positive values? No. So we go back to our original one and we do synthetic division. 1, 8, 16, 5. I'm only going to use the negative roots, aren't I? Let's try negative 1. So we have 1, negative 1, 7, negative 7, 9. Does it work? Nope. So then let's try which one? Negative 5. 1, negative 5, 3, negative 15, 1, negative 5, 0. Here we go. This is a root because we got 0 as our remainder, right? Would you agree? That leaves me with x squared plus 3x minus 1. Negative 15, but 16 was my coefficient, right? It should be plus 1, thanks. All right. The only real number root that's working is negative 5. We already tried negative 1. How do I figure out my other roots? Factor's not going to work. If synthetic division isn't going to work, factoring. Quadratic formula. Negative b plus and minus the square root of b squared minus 4ac all over. That's negative 3 plus and minus root 5 over 2. What do you think these answers are going to be? Are they going to be a positive number and a negative number, or are they both going to be negative? Why? Because there are no positive values. They're all going to be negative. We found that using Descartes' rule of signs. So what are my answers? My roots are x is equal to negative 5, and x is equal to this mess right here. Does that make sense? So you see how the rule of Descartes can really help you. Now we would know that this is a third degree with tails in the first and the third quadrant. We know that it clearly crosses the x-axis at -5, and that it's also going to cross the x-axis at this negative decimal representations, correct? But it's never going to cross it over on the positive axis of x. Okay? X is equal to -5, so the factor is x plus 5. So the graph, guys, would do this. -5, it's going to cross 2 more times over in the negative section. Never in the positive. Have a good weekend. We have to go to